divided by 3 plus j omega. Okay, so please keep this in mind. E raised to minus at u of t have a Fourier transform equal to 1 divided by a plus j omega. I have used that. Okay, so this is frequently used Fourier transform pair, and that is it. And looking at the question, we can see that it is 3 plus j omega the whole square. So when does this 3 plus j omega the whole square come in? That is when it is multiplied by, I will write the property of a Fourier transform. The property of a Fourier transform is okay. Okay, now see, t into e raised to minus 3t u of t will give 1 divided by 3 plus j omega the whole square. Okay. I think you all are familiar with this property of Laplace transform, where t is having a Fourier Laplace transform of 1 divided by s square. The same thing is used here. That is, this is having a particular Fourier transform, and if it is multiplied by t, then it will be changed into s plus a the whole square. Okay, that is only because we know that s is equal to j omega, right? When s is equal to j omega, Fourier transform will change into Laplace transform. So t into e raised to minus 3t u of t equal to 1 divided by 3 plus j omega the whole square. Okay, and now one more thing is to be found out here, that is j omega. When does this j omega come? So using another property of a Fourier transform, that is d by dt of x of t will have a Fourier transform of j omega into x of omega. So this thing is actually x of omega. If it is to be multiplied by j omega, what is the requirement? That in the time domain it should be, so let this be x of t. The whole thing be x of t. In the time domain, if x of t is having a Fourier transform of x of omega, and if it is differentiated in the time domain, it will have a Fourier transform of j omega into x of omega. Using this property, this is an important property. Using this property, we are going to write d by dt of, instead of x of t, we have t into e raised to minus 3t u of t will have a Fourier transform of 1 divided by, j omega into x of omega, right? J omega divided by 3 plus j omega the whole square. Okay. So we have to find out this x of t, that is the inverse, let this be x dash of t. Okay, the inverse Fourier transform is asked here. So we have taken the Fourier transform pairs conveniently so that we will get an answer. So what is x of t? X of t equal to d by dt of t into e raised to minus 3t u of t. Now we have to find out the Fourier transform, the differentiation. Okay, that is x of t equal to t into uv method we are going to use. Let this, the whole thing be u and this will be v. Okay, that is t into d by dt of e raised to minus 3t u of t plus e raised to minus 3t u of t into d by dt of t. Okay, then x of t equal to t into d by dt of e raised to minus 3t u of t. Again we will use this multiplication, that is UV method, that is e raised to minus 3t d by dt of u of t plus u of t into d by dt of e raised to minus 3t plus e raised to minus 3t u of t into d by dt of t is 1. So I am not going to write that. I am rewriting it over here, that is t into d by dt of e raised to minus 3t u of t plus e raised to minus 3t u of t. Okay. So the answer is e raised to minus 3t into d by dt of u of t plus u of t into d by dt of e raised to minus 3t plus e raised to minus 3t u of t, which is equal to t into e raised to minus 3t. The d by dt of u of t is equal to del of t. Okay. So into del of t plus u of t into d by dt of e raised to minus 3t equal to minus 3 into e raised to minus 3t plus e raised to minus 3t u of t. We will open the bracket. When we open the bracket, we will get t into e raised to minus 3t del of t plus t into u of t minus 3, I will write here, minus 3 t u of t into e raised to minus 3t plus e raised to minus 3t u of t. Okay. And we know that x of t into del of t minus t0 will give us x of t0 into del of t minus t0. This is a property of impulse response, property of a delta function. So it is multiplied by what? Del of t minus 0. Instead of t0 we have 0. Okay. So the answer will be, this is our x of t. Answer will be x of t0. That is, instead of t, we are going to replace that with t0. Okay. That is 0 into e raised to minus 3 into 0 del of t. This whole thing will be equal to 0 minus 3t e raised to minus 3t u of t plus e raised to minus 3t u of t. Okay. So the final answer is equal to e raised to minus 3t u of t minus 3t e raised to minus 3t u of t, which is equal to, and taking e raised to minus 3t u of t outside, we will get 1 minus 3t. Okay. Should I change anything? Please respond if I should slow down or something like that. People who are watching it, please can you say something about what should I do to improve this? Is it clear up to? Is it clear up to here? Can I proceed to the next question? Okay. Yes, to the next question. Okay, this is an important question. So, the value of impulse response of a system, excuse me, okay. The value of impulse response of a system, I'll write it, the value of impulse response of a system at t is equal to 3 seconds, whose frequency responses h of omega equal to sine square 3 omega into cos omega divided by omega square. So, we have to find out the value of h of t, that is h of t at t is equal to 3 seconds. This is the question. Okay. So, for that I am going to write h of omega. Here h of omega equal to sine 3 square 3 omega divided by omega square into cos omega. So, instead of sine square omega, I am going to write sine 3 omega divided by omega into sine 3 omega divided by omega. Okay, instead of sine square and omega square, I have written sine omega divided by sine 3 omega divided by omega and sine 3 omega divided by omega into cos omega. Okay. So, for sampling function, there is a function on a sampling function whose formula is sine omega divided by omega. So, that is the frequency should be the same on the numerator and the denominator. So, to make this into a sampling function, I am going to multiply 3 on the numerator and denominator on this particular thing, and here also I am going to do it. Okay. Okay. Now I can write this is actually sine 3 omega divided by omega. I am taking this 3 and 3 outside. The rest will be sine 3 omega divided by 3 omega into sine 3 omega divided by 3 omega into cos omega. Okay, equal to 9 into sine 3 omega divided by, is it? Wait a minute. Now is it clear? Okay. So 9 sine 3 omega divided by omega, I can write, this is actually a sampling function, right? Sampling 3 omega, and the other one is also sampling 3 omega into cos omega, right? So 9 into sampling 3 omega into sampling 3 omega will be sampling square 3 omega into cos omega. Okay. And now I am going to give another important Fourier transform pair, that is a triangular t divided by t. Instead of before that, I'll give another Fourier transform pair, that is a rectangle t divided by t will have a Fourier transform of at sinc ft. Okay, please keep these formulas. These are very important for Fourier transform pairs. So please keep these formulas in mind, and also don't forget to keep that in the formula book. Okay, a triangle t divided by t will have a Fourier transform of AT sinc square FT, and this is one Fourier transform of A triangle T divided by T. Also, it can be simplified as AT sampling square omega T divided by 2. In this question, this is x of omega, right? In this question, actually h of omega, I am sorry. No, this is x of omega. We have only taken this part, right? I am going to take it as x of omega. So, x of omega is this, okay. So, x of omega equal to 9 sampling square 3 omega, okay. I am just going to take this part. 9 sampling square 3 omega. So, we have to find out the inverse of this function, inverse of this Fourier transform. So, what we have here is equivalent to this. So, it will have an inverse equivalent to this one, right? So, I am just going to find out the value of A, T and all, okay. So, instead of AT, we have 9, okay, and instead of omega T divided by 2, we have 3 omega, okay. So, omega and omega cancel out and T is equal to 6. And now substituting here, A into 6 equal to 9, and so A equal to 9 divided by 6, which is equal to 3 divided by 2, right? So, this triangular function will be equal to, that is our x of t. This is x of omega, then its inverse will be x of t, okay. So, x of t equal to, instead of A, we can write 3 by 2 triangle T divided by period is 6, okay. So, that is equal to 3 by 2 triangle T divided by 6. Is that clear? Up till now, x of t so 3 by 2 triangle T divided by 6 gave us a Fourier transform of 9 into sampling square 3 omega, okay. Let this be omega, let this be x of t, okay. So, I am going to plot this, okay. If I plot this, the triangle will be like this. 6 minus 6, this 6, okay. 6 minus 6 and with an amplitude of 3 by 2. So, this is our x of t, okay. And now, I am going to come back to the question. Our h of omega was originally 9 sample square 3 omega into cos omega, okay. This is our x of omega, we have already written it. Instead of cos omega, I am going to write e raised to j omega plus e raised to minus j omega divided by 2. No problem, right? And our h of omega will be equal to x of omega into e raised to j omega plus 1 by 2 into x of omega into e raised to minus j omega, okay. And now we are going to use the property of a Fourier transform and see when does this e raised to minus j omega come up with a Fourier transform x of omega. So, I am just going to write the property here, that is x of t having a Fourier transform of x of omega, and if x of t is multiplied by, shifted, time shifting property of Fourier transform. So I am going to use that. So x of t having a Fourier transform of x of omega, and if it is shifted by t0, we will have a Fourier transform of x of omega into e raised to minus j omega t0. If it is shifted to the other side, that is x of t plus t0, will have a Fourier transform of x of omega into e raised to plus j omega t0. Okay. So this also is important. Now coming back to the question, this is omega into 1 and this is also omega into 1, right? So x of omega is multiplied by j omega 0, j omega 1. So here our t0 equal to 1, here also our t0 equal to 1. So if I am writing the inverse, I'll get h of t equal to half. I will write it as it is. So half into x of omega into e raised to j omega will have an inverse of x of t minus, okay. Now this x of t, we have already found this. X of t is a triangular function, minus 6 to 6 x of t into 3 by 2. And now the question is x of t plus 1, that is equal to x of t plus 1, that is it is going to be shifted to the right hand side, the left side by 1. So if it is shifted to the left side by 1, it will look like this. I'll write it on the other side, okay. So x of t is this, 6 to minus 6 x of t, okay, and our h of t, that is what is we are going to find out. H of t is equal to half into x of t plus 1 plus x of t minus 1, okay. Now h of t equal to, that is x of t plus 1 equal to, that is it is going to be shifted to the left hand side, left hand side by 1 unit, that is it will look like this. Shifted to the left hand side by 1 unit, that is when there is minus 6, it will be minus 6 minus 1, that is equal to minus 7, and here it will be 5. So the answer, and the amplitude will be, the original amplitude was 3 by 2 and it is going to be multiplied by 1 by 2. So the given amplitude, that is half into x of t plus 1 amplitude will be 1 by 2 into 3 by 2, that is equal to 3 by 4, okay. This is our x of t plus 1 and it is added with the other one, x of t minus 1. That is it is going to be, our x of t is going to be shifted to the right hand side by 1 unit, okay. That is equal to, where this minus 6 is coming, it will be shifted to the right side, okay. That is 6 plus 1, that is 7, and this will be minus 5, okay. Here also the amplitude will be equal to 3 by 4. Now the thing is that we have to find out the slope, and also this is a very good question actually. We have to find out h of t at t is equal to 3. H of t is actually the sum of these two. So we have to find out and what and all changes will be there, or the new figure when this happens, okay. So please have a look at this figure. Let this be x2 of t and this be x1 of t, okay. I'm just going to mark it as x1 of t and x2 of t. Our x1 of t starts from minus 7 and x2 of t starts from minus 1. Sorry, minus 5. Okay. So, this is going to be added together. That is from minus 7 to minus 5. The only thing that is going to be in the output of these two functions addition will be x1 of t. Okay. Because x2 of t will only be starting from minus 5. From minus 7 to minus 5, x2 of t is actually 0. So, the only thing that will be there is from x1 of t. Okay. So, I am going to write this x1 of t's equation from minus 7 to minus 5. Okay. So, equation of that line is equal to to find out the equation of a line, what is the equation? Y minus y1 equal to m into x minus x1. Okay. So, the starting point, this is x1 instead of y. Then the y axis represent x1 of t. So, I am going to write x1 of t minus y1. Instead of y1, it is starting from 0, right? That is minus 7, 0. That is our y1 is 0 equal to m. So, we have to find out this will be a minus 1 and this will be at 1, okay? Because the peak was at 0 in the original signal, it is shifted to the left side. So, the peak will be at minus 1. Here, it is shifted to the right side. So, the peak will be at the other plus 1, okay? Now, x1 of t minus 0 equal to m. That is our slope. We have to find out m is equal to y2 minus y1. y2 is 3 by 4. That is 3 by 4 minus y1 is 0. That is, it is 0, right? y2 minus y1 divided by x2 minus x1. At x2, that is minus 1 minus of minus 7, which is equal to 3 by 4 divided by 6. That is 3 by 4 into 1 by 6, which is equal to 1 by 8. So, the slope here is 1 by 8. Okay. Into, instead of x, I am going to write x-axis represent time. So, t minus x1. x1 is, it is starting from minus 7. That is t plus 7. Okay. Is that clear? So, x1 of t will be equal to t divided by 8 plus 7 divided by 8. And from 0 less than or equal to t less than or equal, sorry, 0 not 0, I am sorry, minus 7 less than or equal to t less than or equal to minus 5, and x2 of t on the contrary is equal to 0 for minus 7 less than or equal to t less than or equal to minus 5. So, these two are added together. Let it be y of t. Where should I write it? Y of t. Okay. I am just going to write y of t over here. Okay. Y of t equal to, that is the sum of these two. Okay. x1 of t into y1 of t, x2 of t. Sum of that will be equal to t by 8 plus 7 by 8 for minus 7 less than or equal to t less than or equal to minus 5. So, I am just going to keep that there. And now, the next turning point in this equation, we have to see this. So, looking at this x1 of t, we can see that it is going to be the same. That is, this line will not change until it reaches minus 1. So, the turning point in these two equations, that is, these two addition will be at minus 1. So, the next interval we should take is, actually we have reached up to minus 5. Okay, minus 5. Then this thing starts, and this thing is already at minus 1, but it will change from minus 1 because the line is actually changing, right? So, we have to take what is the equation of the sum. What will we get as the sum from minus 5 to minus 1, okay? So I am going to take from minus 5 less than or equal to t less than or equal to minus 1. This function, okay. The same line is taken there, so its function will be x1 of t is equal to 1 by the same function. This will be there 1 by 8 into t plus 7, okay. And coming to this here, from x2 of t equal to, we have to find out, I will write it here, okay, because I have to write this y of t everything over here. So x2 of t at from t is equal to minus 5 less than or equal to t less than or equal to minus 1. So minus 1 will be over here, right? So I have to find out the equation of this particular line. So I am going to write the equation, the same equation, y minus y1 equal to m into x minus x1 will be used. So instead of a y, I am going to write x2 of t minus y1 is again 0 equal to the slope is, these two are same triangles which are actually shifted to the left and right by 1 unit. So it will be having the same slope only. So 1 by 8 into t minus x1, right? x1, instead of x1 it is minus 5 here. So minus of minus 5. So our x2 of t equal to 1 by 8 into t plus 5 for minus 5 less than or equal to t less than or equal to minus 1. Okay. So x2 of t equal to 1 by 8 into t plus 5 for minus 5 less than or equal to t less than or equal to minus 1. Is that clear? So the actual y of t is equal to x1 of t plus x2 of t. So that will be 1 by 8. We are going to add these two, okay. 1 by 8 open the bracket and add, okay. T by 8 plus 7 by 8 plus t by 8 plus 5 by 8, okay, which is equal to t by 8 plus t by 8, we will get t by 4 plus 12 divided by 8, or I can write t by 4 plus 3 by 2, okay. So I can write it here, y of t is equal to t by 4 plus 3 by 2 for minus 5 less than or equal to t less than or equal to minus 1, right? And now we have to see another turning point over here. So this our x2 of t, we will see our x2 of t is continuing this equation until 1, okay. So we have reached minus 1, we have reached up to minus 5 to minus 1, and now we have to find out the other turning point over here is up to 1. So we have to take the equation of both these function from minus 1 to 1, okay. So this function I am going to take, this is our minus 1 less than or equal to t less than or equal to 1 I am going to take, and the equation of this line will be equal to okay, equation of this line will be equal to x1 of t minus 3 by 4, that is our y of t. y1 of t is actually, this is our starting point, right? This is a decreasing slope. Please have a look. This is our starting point. So my y1 is y1 of 3 by 4 equal to slope is minus 1 by 8. This is increasing slope which was 1 by 8. So the decreasing slope will be minus 1 by 8 into t minus of x1. So x1 is, the starting point is minus 1 plus 1. Okay, so x1 of t will be equal to minus t by 8 plus, minus 1 by 8 plus 3 by 4. Is that clear? So, taking the LCM, we will get minus t by 8 minus 1 plus 6 divided by 8, right? So, the answer will be minus t by 8 plus 5 by 8. Okay. So, x1 of t will be having x1 of t is equal to minus t by 8 plus 5 by 8. Okay. And now come to x2 of t. Coming to x2 of t from minus 1 to 1. It will be having the same equation as the same line is there. Okay, there is no change. So x2 of t will be equal to this equation only, t by 8 plus 5 by 8. And now here also we are going to add these x1 of t plus x2 of t equal to x1 of t. We have found out it is minus t by 8 plus 5 by 8, and x2 of t it is plus t by 8 plus 5 by 8. So that will be equal to 5 divided by 4. So I can write it is 5 by 4 from minus 1 less than or equal to t less than or equal to 1. Okay. And next we have reached up to 1, right? So the next is from 1 to 5. Okay, from 1 to 5 we have taken minus 5 to minus 1. The equation is t by 4 plus 3 by 2. But from 1 to 5, minus 1 to 1, minus 5 to minus 1, it was an increasing slope. But from 1 to 5, it is a decreasing slope. Here also from minus 1 to 5, it is a decreasing slope. So there won't be any other change, but the slope will be decreasing. That is t by 4 plus 3 by 4, 3 by 2, 4, 1 less than or equal to t less than or equal to 5. And the last portion is from 5 to 7. So here also it is a decreasing slope. The same equation will be taken, but in decreasing slope. Instead of 1 by 8, we are going to write minus 1 by 8. Okay. So 5 less than or equal to t less than or equal to 7. So this is the equation for y of t. That is, after after adding these two triangular signal, we will get a signal like this. That is t by 8 plus 7 by 8 for minus 7 less than or equal to t less than or equal to minus 5, and t by 4 plus 3 by 2 for minus 5 less than or equal to t less than or equal to minus 1, and 5 by 4 plus 4 minus 1 less than or equal to t less than or equal to 1, and minus t by 4 plus 3 by 2 for 1 less than or equal to t less than or equal to 5, and lastly minus t by 2 plus 7 by 8 for 5 less than or equal to t less than or equal to 0. So 7 and equal to 0 otherwise. Okay. So this is our h of t. This is our thing that we were doing for, and the question was h of t at t is equal to 3 seconds, which is equal to we'll see what is the equation at t is equal to 3 seconds. 1 less than or equal to t less than or equal to 5 will include this 3 seconds, right? So the equation will be minus t by 4 plus 3 by 2. Instead of t, we'll write 3. Okay, 3 by 4 plus, which is equation, taking the LCM, which is equal to 3 by 4. So this is the answer for h at t is equal to 3. Okay, is that clear? Oh, with that I'm so if I am going to draw the curve and draw the signal, it will be like this. From minus 5 to minus 1, sorry, minus 7 to minus 5, the slope was 1 by 8. From minus 5 to 1, the slope is 1 by 4. Okay, 1 by 4. And from 1 to 1 it is 5 by 4. And from 1 to 5 it is